Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 5, Lesson 10, Distance, Perimeter, and Area in the Real World. Now, this lesson has some real world application, and we're going to be doing some measuring in class. So this video is just going to contain a little bit of a preview of what you're going to be doing and also a little bit of review. Okay, so first let's start with reviewing the area and perimeter of a rectangle. So we have a rectangle here, and we have one side of 9 centimeters, one side of 5 centimeters. To find the area, we're going to need to take base times height. If we take a base of 9 centimeters, okay, so base of 9 centimeters times a height of 5 centimeters, 9 times 5 is 45. Our units in this case are centimeters, and they are centimeters squared because it's area. Now, to find the perimeter, we can do a couple of different things. We know the perimeter is the distance around the outer edge. We know this is 9, so then this side would also be 9 centimeters. We know this side is 5 centimeters, so this side would also be 5 centimeters. So one thing you can do is you can just add up all the sides. We have 5 and 5 is 10. Plus 9 and 9 is 18. You end up with 28 centimeters as your perimeter. Another way we could look at that is through multiplication. 9 plus 5 gives you these two sides, but then you have two more sides of the same length, so we could do 2 times 9 plus 5. So again, 9 plus 5 is 14 times 2. Both ways you're going to get the same answer, 28 centimeters as your perimeter. Okay, this problem is a little bit different, a little bit of a challenge. Find the width of the rectangle. The area is 1.2 meters squared, and the length is 1.5 meters. So, this is one where we're using the same formula, but we already know the area. So we're going to have to fill in some blanks here, right? So we know area equals length times width. In other words, we know area is 1.2 meters squared equals length is 1.5 times W. Now, the thing that we don't know is the width. So we have to solve for W. So we're going to use some of our algebraic skills here. We know we want to isolate the variable, which in this case is the W. We want that to be by itself. We see multiplication, so we do division, right? Divide out 1.5, that cancels out. This side we have 1.5 or 1.2 divided by 1.5. So we end up with W equals 1.2 divided by 1.5. If we want to solve it in kind of our traditional standard algorithm way, we can do this. And we know that we don't want a decimal here. So what we want to do is move this decimal over 1, which means we move this decimal over 1. And we end up with 12 divided by 15. 15 goes into 12 0 times. 0 times 15 is 0. We subtract. We end up with 12. But we need to bring down the next number, which is a 0. Which means we have to put our decimal in and also put it above in the same location. Bring that 0 down. Now we have 120. 15 goes into 120 8 times. 8 times 15 is 120. We subtract, we get 0. So 0.8. So the width is 0.8 or 0.8 meters. Okay, let's do one more example. This one's a little different. This is similar to something we're going to do in class. So in this case, we're going to use the example of a door. And I'm going to give you the measurements, but in class you're going to be measuring some just standard items that you'll see throughout the room and we'll talk about. So let's say we're going to measure a door. And we're going to measure that door in feet. Well, we want to measure to a certain amount of precision, right? So we want to measure to the nearest what? Well, we're going to measure to the nearest half foot. So if we end up with 1.4 feet, we'll round that and we'll call that 1.5 feet. You'll be making a prediction. We're not going to do that here. And let's say we measure that door. So we go up to the door, we measure it, and the width is 3.5. The length is 6.5. So to find the area, we're going to need to multiply 6.5 times 3.5. And I'm going to convert those to mixed numbers. So we're going to use our MAD strategy. Multiply, add, denominator stays the same. So 2 times 6 is 12, plus 1 is 13. Denominator stays the same, so we have 13 halves. Times 2 times 3 is 6, plus 1 is 7. Denominator stays the same. 7 times 13, 7 times 10 is 70. 7 times 3 is 21, so we end up with 91 over 2, 91 halves. And if we, I just realized a little error I made here. So we needed to multiply across. So we do end up with 13 times 7 is 91, and then 2 times 2 is 4. That makes a lot more sense. 91 divided by 4 is going to give us 22. 22 times 4 is 88. We have a remainder of 3. So we're going to end up with 22. The remainder is our new numerator. Denominator stays the same. 22 3/4 feet squared. Now to find the perimeter, we're going to do the same thing we did on the last question, on the last problem. And we're going to go back to our original picture. So we know that this is 3.5, which means this is also going to be 3.5, same distance. This is 6.5, so this turns into 6.5. So now we can just add. 6 and 6 is 12. 3 and 3 is 6. 6 and 12 is 18. 1/2 and 1/2 is 1. 1/2 and 1/2 is 1, so 1 and 1 is 2. So we're going to end up with a perimeter of 20 feet. All right, so we'll look at some examples in class, and we'll have you actually do some measuring and find some area and find some perimeters, and we'll do our normal exit tickets and all that as well. So thanks for watching. We'll talk to you soon.